Okay, here is an introduction to chapter 7, to 7.1. Uh, we have inequalities. Inequalities are known as less than or greater than, less than or equal to, greater than or equal to. Here's an example here, 3x plus 2y is greater than or equal to 6. There's many ways of graphing this, but what you look at first is you look at the equal case, and this is basically the graph of a line. Linear means line, so these are going to be lines. There is the rise over the run, there is slope and y-intercept, but the easier method here, in terms of how to graph this quicker, other than a graphing calculator, would be to pick x to be 0 and get an answer for y, and pick a y value to be 0 and get an answer for x. This is called the intercept method. These are called x and y intercepts respectively. So if x is 0, you plug it into the function, that goes away. 2y equal to 6, and divide both sides by 2. You get 3. Now if y is 0, 3x equals to 6, in which case you divide both sides by 3, and essentially that cancels. And you get x equals 2. So you have your two coordinates, 2, 0, and 0, 3, which is this one and this one. Then you connect the line between them. This shading is going to come from this idea here. So the idea is if it's less than or greater than, if there's equals, it means it's a bold line. If there was no equals, this would be a dotted line. But for the meantime, it is equals. So you pick a point that's not on this line, on either side of the line. For simplicity, I picked 0, 0. So if x is 0 and y is 0, what would happen? Would this thing be true or false? So if you put 0 for x and 0 for y, the left side is 0. 0 is not greater than 6. So everything over here is false, which means everything on this side has to be true. So these are the answers. So we shade on this side. Had this been true, we'd shade on this side. It just depends. So if it's true, you shade on that side. If it's false, you shade on the other side. And that's how this works. That's all there is to it. Another example here, and again, you can read the information is what I'm saying. The next example here is x plus 2y is less than 2. So this is less than, so notice a dotted line. So it's dotted because you don't actually include the line as the answer. So if it's no equals, this is a dotted line. If it's equals, it's a bold line. Just want to make that clear. So again, you pick x to be 0. Here's the work. Here you get y to be 1. You pick y to be 0, x is 2. So your point 2, 0, your point 0, 1. Connect a line dottedly, in dotted fashion. Notice again, 0, 0 is clearly not on the line. So we plug in a 0 here and a 0 here. 0 is clearly less than 2. Clearly. So because 0 is less than 2, 0, 0 is true. So everything on this side of the line where 0, 0 is located is also true. So you shade all that region. So this is the graphical solution of this inequality. So the answer is the graph, essentially. Those are the answers. That's how this works. And hopefully that's not so bad. Then you talk about a system of inequalities, which you have more than one inequality, and hopefully you can kind of see it all here together. I'll explain this here momentarily. A system means you have more than one inequality at the same time. So using this, you say negative 2x plus 5y is less than or equal to 10. So you look at the equal case. Again, picking x to be 0 and y to be 0. When x is 0, here is the work, y is 2. When y is 0, here is the work, x is negative 5. So that would be this line coming across. Negative 5, 0, and 0, 2. Connect the dots. And again, it's a bold line because it's equals. Now, x is less than or equal to 3. You look at the x equals 3 version. But when you're graphing a line, if it's just x equals a number, this is a vertical line passing through that point on x. So here is x equals 3. There is your vertical line. That's x equals 3. Y equals 2 again, because y greater than or equal to 2, this thing says y equals to 2. Y equals to 2 is a horizontal line. So the idea is you're trying to figure out where this is going to work. So you want to look at the place where they're all shaded at the same time. So notice that here x equals to 3, and the original one is x less than. So x is typically, if it's just x, you're talking about right and left. So if this is 3, less than would be to the left of. So I'm going to shade everything to the left of this line. Okay? Then y is greater than or equal to 2. If it's just y by itself, this is the y value. Greater than y, y greater than something means above, y less than something means below. So I'm shading above. So I know that I'm going to shade together this vertical line, this horizontal line, they meet in this little region here, in all this little region. Now it's where the line intersects both of those that we're going to intersect all three. So at the point 0, 0, if I put a 0 here and a 0 here, as it was over here, let's see, that is clearly less than 10. So this line, I'm going to shade everything under. So if you can imagine, I'm going to shade everything under this line to the left of this line and above this line. Where they would all meet together would be the middle, the little triangle. That's where they would all intersect. So where they all intersect, that's a solution. These three edges, or these three what are called corner points, or vertices in this case, these corner points represent kind of like the boundaries. So 0, 2, just to point that out, this is the point 2, 3. Now this point is 3, 16 over 5. Now this part right here, just for your knowledge, is essentially where this line intersects this line. So when x is 3, you plug in a 3 for x here. So that's -6. If you add 6 to both sides, you get 16 here. If you divide both sides by 5, that's where you get that point. So the intersection point is when x equals 3 meets -2x plus 5y equals 10. This point here, 3, 2, it's when the y equals 2 line meets x equals 3 line, so you get the point 3, 2. So these are what are called the vertices. They will be important in the next section. For right now, I just want to know that that's where they meet. Just kind of blown up a little bit, that little triangle, so you can see it better. That's how it looks. That's the solution to this this system. And that's how this works. Okay. So the shading is the shading of all three graphs intersect at the triangle in the middle. The triangle is the solution to the system of linear equations, where these represent the corners or the vertices. I'll put one more here. Hopefully this is not so bad. Two lines here, or two inequalities. X plus y is less than or equal to 750. 5x plus 4y is greater than or equal to 2500. So I try to do it purposely where these numbers are not fractions or decimals. So hopefully the numbers come out nice. So without showing the work here, when x is 0, y is 750. When y is 0, x is 750. So that's where you get that. So again, 750 is here on the x, 750 here in the y. Now you're not going to come by 1, so I kind of estimated here. So there's the first line. Then the second line, when x is 0, 4y equals 6500, or divide both sides by 4, y is 625. When x is 0, when y is 0, 5x equals 2500, which means x is going to be 500 when you divide both sides by 5. And so that's this point here, 500, and then 625 is up here. So I connect the dots, and I make a line. Again, bold line because equals. Now x greater than or equal to 0, y greater than or equal to 0. X equals to 0 is the y-axis. Okay. Y equals 0 is the x-axis. So if I want x greater than or equal to 0, x greater than or equal to 0 is this line. X is to the right. So I put these little arrows to show I'm going to shade to the right of the y-axis. Y greater than or equal to 0 means I'm going to shade above the y-axis. So I put these arrows here to kind of show I'm going up. So quadrant 1 is where these two inequalities meet. The next two depending on what the values are. So where the shading is. So if I pick 0, 0, if I pick 0, 0 for both inequalities, 0, 0 for the first one, you get 0 less than or equal to 750. So I would shade essentially everything down here of the top line. But the other line is when you plug in a 0, is that bigger than 2500? No. So the second line, this line, I'm not going to shade underneath. I'm going to shade above. So I'm going to shade above the first line, below the second line, to the right of this line, above this line. So they all would intersect in this little parallelogram, this little four-sided figure. And then these would be the edges or the corner points or what's called the vertices. And so this is the answer to the problem. And that is quick summarization essentially of 7.1. 7.2, the reason I'm going to do it together is because it's basically the same thing, except you're going to have one extra thing. You're going to have what's called linear programming. Now, it sounds fancy, but really is you're trying to kind of get a business model, a small business model as to how you would have a maximization or maximizing, what's called optimization. Optimization is you're trying to get the most out of your scenario, or your least out of your least or your most, your minimum or your maximum. There's an objective function that tells you more or less how to find the min or maximum, along with constraints. Now, the constraints are going to be your linear inequalities. So the previous section showed us how to solve a graph with a system of linear inequalities. So we're going to do a lot of the shading. But what's going to make this different is they're going to give us another equation, what's called an objective function. We're going to take the corner points, if there are any, of the intersections of all the system, and we're going to plug them into the objective function. Whichever one is the biggest answer is your maximum. Whichever one is the smallest answer is your minimum, if they occur. Sometimes you might not have minimum or maximum. Sometimes you might have both. It just depends. So find the minimum and maximum values of each of the following objective functions subject to the given constraints. So this is, again, just a random function. It's just a random equation that kind of dictates how your min or max is determined. So you have constraints. You're given these four inequalities. Okay, so I have 3 lines here, essentially 5 constraints, excuse me. So in the first one, notice like the previous one, I plugged x to be 0 and y to be 0. When x is 0, you cut out the x. So 2y equals 6, divide both sides by 2, you get 3. When y is 0, 3x equals, my finger's too fat here, 3x equals 6. So you divide both sides by 3, and you get an answer of 2. Same thing over here. You plug in x to be 0, you get y to be 2. Plug in y to be 0, you get x to be negative 4. Now, I didn't show the steps here because I'm hoping that's kind of trivial. You can kind of figure that out. Over here, x plus y equals to 1. When x is 0, y is 1. When y is 0, x is 1. Here, this is the y and x axis. So, if I can here, let me see if I can. Again, x equals 0. Because it's greater, I'm going to shade everything to the right. So that's why you see the arrows. Here is y equal to 0. Because we're talking about y greater than 0, it's this part. So arrows show that I'm going to shade up. So again, most of the time we're going to be in the first quadrant because that's when you get like real life situation where, x is a positive something, products or price or profit, or, and y represents, also ticket price or profit or demand or supply. So we're typically in this little area. Now, the first line here, 0, 3, 2, 0, 0, 3, 2, 0, that's the first line here. That is your 3x plus 2y equals 6. Your negative x plus 2y, when you have 0, 2 as an x-intercept, as a y-intercept, negative 4, 0 as x-intercept, is this one. And then the 0, 1, 1, 0, when you have x plus y equals to 1, is this line. So you see those 3 lines cutting across diagonally, and then you have the x-axis and the y-axis and the x-axis. There's 5 lines. Now, if I put a 0, 0 here, because it's less than, it's going to be true. So I know I'm going to have to shade down here. So I put arrows in this line. So I know I'm going to come down. And this one, if I put 0, 0 here, that's clearly less than 4. So that would be this line. Because 0, 0 is down here, I'm going to shade this way. So notice how I put the arrows going down here. So I have arrows this way, kind of downward under this line. Under this line, to the left of this line. Now x plus y, when I put 0, 0, that's not greater than 1, so I'm going to shade to the right. So I'm going to shade to the right of this line, to the left of this line, under this line, right of this line, above this line. So all of them intersect with this 5-sided figure. So there's 5 edges here, or 5 corners. Now these four here are pretty easy to figure out because they're intercepts. 2, 0, 1, 0, 0, 1, and 0, 2. But now this point is where the line negative x plus 2y equals to 4 intersects 3x plus 2y equals 6. So I'm up here. and I want to figure out what's that intersection point. So I'm gonna cancel x's. So I'm gonna multiply both sides. This is the second equation by 3. So I get negative 3x plus 6y equals to 12. In doing so, I cancel the x's here. So I'm gonna go ahead and put that in. That's what I want to do. I want to cancel x's. And now it leaves me with y. 8y equals to 18. If I divide both sides by 8, I get 18 over 8, which simplifies to 9 over 4. So I'm going to put 9 over 4 back into the problem, into the first, and it really doesn't matter which one. I could put it into either one. I'm going to substitute it back into the second one. So I get 18 over 4, which is essentially 9 over 2 when you reduce it. So I'm going to subtract 9 over 2 from both sides, but this is a 4 over 1 minus 9 over 2. I'm going to multiply the first equation by 2 over 2. Because I want to get common denominators. So this is 8 over 2 minus 9 over 2 gives you negative a half. Then I have to divide both sides by negative 1 to cancel this negative. And so negative divided by negative is positive. So 1/2. So this is the coordinate 1/2 comma 9 over 4. And these are the other 4 coordinates. So we're going to take these 5 coordinates and we're going to plug them into the objective function. What I mean is, this is x, that's y. This is x, that's y. So at 0, 1, which is this point, x is 0 and y is 1. At the point 1, 0, 1 is x, 0 is y. At the point 2, 0, 2 is x, 0 is y. At the point 0, 2, x is 0, y is 2. And hopefully you get the point here. As x, this one, x is 1/2 and y is 9 over 4. 1/2 in for x, 9 over 4 in for y. So as I compute all 5 answers, notice that the biggest answer I get is 20 out of all these 5 answers. The smallest answer I get is 4. So the minimum is 4, and it occurs at the point 1, 0. The maximum value is 20, and it occurs at the point 1/2, 9 over 4. So I have a min of 4 at 1, 0, and I have a max of 20 at 1/2 comma 9 over 4. This little thing right here is the answer to the whole problem. This is the graphical solution, but the optimization leads to these 2 answers, and that's one problem. So it's not difficult, it's a lot of work to kind of get everything lined up. So I just want to point that out. Okay, let's do another one here. So my objective function here in this one is 7x plus 5y. My constraints are these 4 things. So these 4 lines, again, x equals 3 is a vertical line. So I'm going to look at the equal version to graph. Sorry for the mess up there, but that's x's. So I'm going to have y's first. So x equals 3 is this, that's where I'm getting this vertical line here. 3y minus 2x greater than or equal to 0. We look at the equals case first. If x is 0, that should be, let's see, if x is 0, so is y. So 0, 0. So here, I can't pick y to be 0 again because I'm going to get the same answer I get at the beginning. So here, this point is actually passing through 0, 0. We pick another point at random. It doesn't matter. I chose x to be 3 because when I plug in 3 here, I get negative 6. So add 3 to both sides, add 6 to both sides. 3y divided 6 divided by 3 is 2. Just for a nice answer, just pick a different version for 3 to get an integer as an answer. So you have to pick a different number than 0, 0 here. So 3 then 0 for y. So 3, 2. The point 3, 2 is kind of small here, but the point 3, 2 right there, and 0, 0. So this line is 3y minus 2x equals to 0. Then let's see, y plus 8x is less than or equal to 52. So when x is 0, y is 52. But when y is 0, notice I get a fraction. I get 52 over 8. But when you divide it out, you get 13 over 2, which is 6.5 essentially. So I just put it as a decimal for simplicity, but you can leave it as 6.5. So that is roughly here. And I just kind of estimate it off a little bit. 6.5 and 52 somewhere up here. So just that's my second line. Then my third line over here, x is 0, y is 2, y is 0, x is negative 1, which would be essentially let's see here. At negative 1, 0, that's this point, and then 0, 2 is that point. So this is that line. Then I go into the matter of fact of picking values. Again, knowing that if x is greater than or equal to 3, we're going to shade this to the right of 3, so this line. When I pick 0, 0 for this line, let's see here. Y minus x is less than or equal to 2. So less than, 0, 0 is going to be less than. It's going to be down. So I'm going to shade under this line. So that's what the arrow is. Now, at this line, if I put 0 in for y, 0 in for x, that's clearly less than 52. So that is this line. So I'm going to shade where 0, 0 is in relation to that line, so down. So I'm going to shade down, down. Now the problem with this line is it doesn't fall on 0, 0. So you pick a point that's not on the line. So it doesn't really matter what you pick. I think for this one, I picked the point 10, 0. The only reason I was so was so adamant was just to make it notice that for sure that 10, 0 is way over here. It cannot be in this line. So 10, 0, I get let's see, I get negative 20. Negative 20 is not less than 0. So here is false. So I'm going to go this way. So where all lines intersect, again, this is four-sided area. This is what we call quadrilateral. So 0.38, again, is where this line when x equals 3 meets y minus 2x equals 2. So I plug in a 3 here in for x, and essentially I get y to be 8. So that's how I got that point. This point is when x equals 3 meets this line. So I plug in 3 in for x, and I get y to be a 2. So I get this point. This line and this line. So you have 3y minus 2x equal, or this line, and you can intersect what? Y plus 8x equals 52. So down here, what I did was I tried to cancel x first. I multiplied by 4, and I cancel x. So I did my work, and I got x to be 6 and y to be 4. So that's the coordinate where they all intersect. I don't know what happened here. Oh, sorry. Okay. So y equals 2, y minus 2x equals 2, and y plus 8x equals 52. That's this line and this line. I multiply both sides by, or the first equation by 4 to cancel the x. And so this should be essentially here what? Over here, this should become 5y. This is like an 8 because I canceled. I'm sorry it's so small here, but let's see here. Kind of multiplied. That's a 5. I canceled. So 60 divided by 5 is 12. So I got the point 512. So these points that I'm getting are from this work, essentially. And then what I pointed out earlier as well. So these are my 4 answers. I'm going to put these 4 answers into the original function. So I have an x value of 3, a y value of 2, and plug in x to be 3, a y of 2, x of 3, y of 8, and then put those in there. And then 6 for x, 4 for y, and then 5 for x, and then 12 for y. You put into your calculator, you just get the answers. You get 4 answers, the biggest answer being 95. So your maximum is 95, and it happens at the point 5, 12. Then you have the smallest answer, 31. That's your minimum at x equals 3, at the point 3, 2. And this is the first. These are the first 2 sections of chapter 7.